So basically I'm just going to ignore it, and so are you guys, okay? And yeah, we're just going to do lesson like it's normal. Okay, so today what we're doing is we're looking at polymerisation, and in level 2 you're going to find that it always involves an alkene, which is what we've been doing so far. Now, when our lesson on Monday, I will recap all the reactions of alkenes and give you a reaction map with all the ones we've done so far. So alkenes have a double bond. Okay, so this is the smallest alkene that you can get. And what we're going to find is if you have lots of these, they can actually join together and that forms a polymer. So polymerisation is where you get monomers joining to polymers or forming a polymer, and I'll show you shortly. Polymers are like our plastics. So you might have heard of polyethylene, polypropylene, polyvinyl chloride, polystyrene. The words that I've always got the word poly in front, and it means that they're a plastic. Next year we're going to do condensation polymers, but this year we're just doing addition polymers. You do not need to know this, but it's kind of where does the word come from, okay? So it is the making of plastics, and it's an addition polymerisation is the process. So we're always going to find the monomers add together, and that's where the addition comes from. Your poly is a word meaning many, and you will be familiar with that in like maths from polygons. Any other poly words you know? As where you get lots of peptides joined together. Well done. See? Intelligent there. The mer means parts. Okay, I don't know where that originates from. So polymer means that there's many parts. And we're going to keep it nice and simple, and that we're just going to have one type of part, so one type of monomer, and we're going to be joining them all together. So you're going to get to do your SciPad on your own today, and I've sent you a PDF.
That's really nice.
Trumpet playing in our background. Okay, so you might get asked what is the name of the monomer, in which case this is ethene. Okay, so 2 carbons, double bond, so the monomer is called ethene. Now the next thing you might get asked is what is the name of the polymer? All you do is you write the word poly, and then you look back to see what the monomer was called, and you just write that name. So polyethene. So ethene is the monomer, so that is the monomer there. And you have lots of these, not just 3, like maybe 3,000 or 3 million, like lots. But we're not going to draw more than 3. And you'll often find a question says, draw 3 repeat units. And what they're wanting you to do is to draw 3 monomers and then show them joined together. So when they join together, what happens is the double bond breaks. Oh, hello. That's exactly what I said all of last week. The double bond breaks. Okay, but only one of those, so the single bond stays there. And then it joins onto the adjacent monomer. Double bond breaks, joins onto the adjacent monomer. And so what you'll get is we do draw a single bond with nothing on it, just like a loose end. This is that single bond there. And then this bond is joining onto the adjacent monomer. So this here is the new bond. Okay, so that effectively breaks that one, and then that's joining on. Follow? Okay, so this bond breaks, and that's where it joins on. So that's the existing single bond, and that's the new bond. Okay, so that's the existing bond, and then you just show these little bits hanging off, because in reality you're not going to just get 6 carbons. It's more likely to be 6,000 carbons, but we typically will find in an exam question, and we're going to do lots of exam questions today. They'll say show 3 repeat units, and that's what they mean. 3 monomers, and then what you'll find is there's always 2 times the carbons for the repeat unit. So if there's 3 repeat units, 2 times 3 is 6. So So that's 6 carbons in the backbone, if you like. So backbone is like the main part. What I'll do now is I'll go through polypropene with you and just show you how it can actually get quite sort of, not complicated. If you know what you're doing, it's actually surprisingly straightforward. Okay, so let's go on to another example. Now, if I was to ask you to draw propene, how many carbons has propene got? 3. So typically a student would draw this. It's got a double bond. It doesn't matter where you put your double bond, okay, whether it's here or here, makes no difference. And then what they'll do is they'll draw this. They'll put 2 H's, which makes that 4 bonds. They'll put 1 there, and that makes 4 bonds. And then they'll do 3 there. That is propene. That's correct. But when you go to draw the polymer, it's incredibly difficult. That is not how I would draw propene if I was doing polymerization. All my monomers, I start off, this is how I would do it, and I recommend you follow exactly what I suggest, okay? Draw the double bond like that. Then, off this carbon, yes, it's got an H and an H, all good? Off this carbon is an H. Now this is the trick. Do not draw the CH3 out to the right hand side here. Instead, draw it down like this. Now it will make sense in a second. So what I'll do is I'll just draw 3 repeat units. So I'll put 1 here. So this is another propene. Okay, so that there is one monomer, second monomer, following, and then I'll draw my 3rd monomer. Now, if you've drawn it like this, and this is propene, you've got 3 carbons, double bond, so that is a propene, but all I've done is I've put this down below. So now when I draw the polymerization, I would draw this, but instead of having a double bond, I'm going to break that double bond. Okay, so this was a double bond in here, but now it's just a single bond. And then this enables it to join on to the next one. And so that's when I'd start drawing this one. H, C, H. Okay, now this was a double bond here. Okay, that was a double bond, but that breaks and it allows it to join on to the next adjacent monomer. And you just keep repeating, and this here would be 3 repeat units shown, okay, and that there. So the new bonds is here to this monomer and here to this monomer. Had you drawn it like this, it's impossible to draw the repeating like polymer section. You do need to put the CH3s. Now it doesn't matter if I had put them up or down. So had you, and you can spice it up if you wanted to. You might get yourself confused, but it wouldn't make it wrong if you had done that, because that's still propene, right? It's just that you would then perhaps put that one there as the H3. Follow? Okay. So what I'll now do is just do one more that's a complicated one, and then I'll let you work through some examples, and that's basically addition polymerization done. We'll do some exam questions and we can call it a day. So butene, you can probably take what I've just taught here and apply it yourself, but I'll do it and then, okay, so, this is just a digital version that I had prepared earlier. Notice it's got the CH3 here, so off that carbon, CH3H, HH. So if you flipped back to that previous, when I'd drawn it up, I put all my CH3s in those positions. It makes no difference. It's still polypropene. Right, so this is not how you would draw your butene because you can't draw the polymer section easily. Always start with a double bond like this and then just put your, so that's where the things are going to attach. Following? So that's this bit here. So I can put two H's, so that carbon's got two H's. This carbon has got an H. Now this is not easy. What you've got here is CH2 and CH3, and it kind of takes up space. So I might just draw this double bond a bit bigger to give myself some more space. Okay, so CH2, CH3. And then the next monomer, so CH2, CH3, and then double bond. And one more. So CH2, CH3, and then once you've done that, you've got the hardest part done. And all we do is we break it up to show the polymer. You'd go H, and then you'd have your CH2, CH3, single bond, HH. You can see it starts looking quite messy. H, CH2, CH3, CH, H, CH2, CH3, CH. What you might find in some of the old textbooks or old sort of notes is there might be brackets around like so, and every now and then some people put an N which shows that it goes continuously, but I recommend if they have asked you to do 3 repeat units, you do not put the N in, because this is exactly 3 repeat units, like that's all they are going to be asking for. There is another butene that you could get asked to do, and that's because that's but1ene. Okay, so this is but1ene, and the other one that you might get is but2ene. Now but2ene has got 4 carbons, as you'd guess from the word but. 2 is where the double bond is, and so if you were drawing but2ene out, it would look like this. But that's not how I would draw my monomer. Okay? If I was drawing the monomer, what would I start with? What are the very first 2 atoms you put on the page?
This double bond.
The double bond. Okay, which is this bit here. What comes off these top bonds? H's, well done. And then what would you put off these bottom bonds?
CH3.
Ah, you guys are pros. And then you just go through that process again. So notice that but1ene gets these little bits, whereas but2ene would get CH3s on every single carbon down below. There you go. So that's addition polymerisation. The questions that you want to do are in the NZIC exam papers. So today you can fill in page 168 through to 173. Girls, you'll notice 170 is not there. It's the making of the slime. We'll do that when it's an appropriate day. I just want to get the content taught to you. I know you sort of want to have fun, but it's also mindful that exams are looming. And these exam questions, they're very short. Like, all they're going to ask you to do is draw the monomer, draw the polymer, and there might be an explanation about what is a polymer. So it's just many monomers joining together. Okay, let's get on with it. And we can pause.